Okay, today we're going to do a quick review of the laws of sine and cosine. And our first example right here is actually from middle school, where we're given a right triangle and asked to find the missing side. Well, back in middle school, we would have used Pythagorean theorem to solve for our missing side. So why do I start here? I want to remind your brains that we've been given triangle problems and asked to find missing sides or missing angles, and we have done this in the past. So first we learned how to find a missing side with Pythagorean theorem. Then we were given right triangles and we were given an angle and an opposite side, and we solved it using our right triangle trig knowledge, right, our acronym of SOHCAHTOA. And we realized if we were given an angle and its opposite side and we wanted to find the hypotenuse, then we would use sine, right? And we would take the time to do the problem and set it up. Sine of 40 degrees is going to be equal to opposite over hypotenuse. And we would do some algebra and solve for C and find that the missing side is 15.5. We learned how to do that first in geometry when we did right triangle trig, and then you did it last year in Algebra 2 trig, and we even did it again this year. So our brains, once again, have ways and have experience solving for missing sides or missing angles in triangles. So what's different about today? Well, today we're looking at triangles that are not right triangles. So we can't use Pythagorean theorem. We can't use our right triangle trig using the acronym SOHCAHTOA. So what can we use? Well, right here, I'm going to notice something. I'm going to notice that they give me an angle and the length of the side that's opposite my angle. Whenever I'm given this, I can use what's called the law of sines. So here it says the sine rule. Let's scoot to the next thing real quickly. So the sine rule, same thing as law of sines, says that if you can find your sine, well, the sine of angle A over the side A, so the ratio of sine of A over side A is the same as the ratio of sine of angle B over B. So, over B. So we're looking at this triangle right here. I know there's a lot of stuff going on, but if you can look at this and make some notes that the capital A represents an angle and the small a represents the side that's opposite angle A. So same thing here, angle C, the side opposite is little c, and angle B, and the side opposite is little b. And so what's true is that every triangle has this same proportion where the ratio of the sine of one of its angles over the length of the opposite side is the same as the ratio of the sine of another one of its angles over the length of its opposite side. So pretty cool. I also wrote it down in a different way. You can also see the law of sines written like this. Same thing, right? The ratio, if we were to talk about, oh, I need to go into this. Someone stop me. If we were to say 10 is to 5 as what? 20 is to 10 as 30 is to 15, right? That's true. Those ratios are all the same. We could also say 5 is to 10 as 10 is to 20 as 15 is to 30. And that's all we're seeing here. You usually are going to see the law of sines this way, but every now and then you'll see it flipped, and that is just fine. Fine. So let's go ahead and go back to our problem that we were looking at. Once we know that we have an angle and we have the measurement of the opposite side, then we can go ahead and set up our law of sines. And we did this in class. And so if you look at what we did, we said sine of 50 over 12 is the same thing as equal to sine of 75 over its opposite side C. And so our goal here when we're given a proportion is to cross multiply. And that's what we did with the second step. Moving here, we cross multiply. And our goal is to get C by itself. So to do that, we divided both sides by sine of 50 degrees. And that gave us this. When we finally isolate C, as we did in this step, we're going to put all of this in our calculator, and that leads us to our answer that side C has the length of 15.1, which makes sense for this given triangle, right? That's reasonable. If the side opposite the 50-degree angle is going to have the length of 12, then the side opposite the 75-degree angle would have a larger length of 15.1. So that's how we use the law of sines. I also wanted to note that this particular triangle that we're working with is an example of angle, angle, side. We're given an angle, and a side that's not included in between those two angles. Is that really important? It's interesting. It's going to be important in just a little bit when we really do have to identify what type of triangle we have. But we'll get to that in a little bit. All right, we did that. So another situation you're going to have with using law of sines is you're going to be given dimensions. It says you're going to be given an angle, two angles actually, and a side, and you're going to be asked to find the remaining angles and sides. I need to slow down. I'm feeling pressure because the bell's going to ring, and I need to get this done before the bell rings and the students come pouring in. All right, here we go. So I'm going to start my sketch with the biggest angle, angle A, and I'm going to, once again, we don't have to be perfect because we can't be perfect in our sketches, but I'm going to start with angle A and make it be reasonable, make it reflect something that really is 120 degrees, an angle that's 120 degrees. And then I'm going to go ahead and I'm going to pick, let's pick this one to be 45 degrees. And we can, so there we go. This also looks, that looks like 45. I'm going to put the B there and the C there. Could I have drawn the triangle with A and then the B at the top point and C at the other point? Sure, it doesn't matter. And then we see that side C is the side that's opposite angle C, so I'd write it right here. And we note right away when we draw it that we're actually dealing with an angle, side, angle, triangle. Once again, don't worry about this part until I tell you to start worrying about it, or not worrying about it, just paying attention to it. So we look at this and we ask ourselves the first thing, are we given an angle and its opposite side? And we're like, no, we're not. We can't use the law of sines. And then we stop and say, actually, we can, right? If we know this angle's 45 and this angle's 120, we're going to add them up together, right? Which gives me a 165. And then we're going to subtract the 165. So to find out that my missing angle is 15 degrees. And now we've got an angle and its opposite side. But everything's circled in green. That's not going to help, is it? So let's see. Let's circle it in red. So now we have our angle and the opposite side. So now we can set up our, let's see, I'm going to do this. Now we can set up our, let's see if I can make this bigger. Okay, that's not good. All right, now we can set up our, I'm going to have to walk over to the computer. Now we can set up our law of sines, and we did this in class. So I just went ahead and kept the work so that I could make the video just a little bit shorter. Now we set up our law of sines, right? We say that sine of 15 is to 16 as sine of 45 is to this side B. So we go ahead and let's see if I can get rid of this. Okay, there we go. So we go ahead, we set it up, we cross multiply. That's how we moved from this line to this line. Once again, we want to get B by itself. So we divided both sides by sine of 15 degrees, right? And that's how we moved from this line to this line. Once we isolate B, we put this whole thing in our calculator. And when we press enter, we get 43.7. Once again, that may seem a lot bigger than the other side, that's 16, but it makes sense, right? Within the same triangle, if an angle only opens up a little bit, like 15 degrees, well, then its opposite side is going to be way smaller than the angle in that same triangle that opens up really wide to 120. that would have a much bigger number. Yes, this drawing is not drawn to scale, but such is imperfection. All right, and so it asked us to solve the whole thing. So what would we do to go ahead and solve for, let's see, we solved for B. Oops, and I wrote that as A. So let's go back here to B, because apparently A is going to be even bigger. So let's back up what I just said, talking about being imperfect. Made a mistake on my video. That's okay. I'll survive. So side B is opposite angle B, of course, which is 43.7. Still makes sense that an angle, side opposite the angle 45 is going to be much larger than the side opposite the angle of 15. And so still not drawn to scale, but that's okay. Let's go ahead and find let's find side A. So I'm going to move all this stuff. It's great that and feel free, because I know that I'm speeding through the work, feel free to slow it down and pause it. Okay, and then to find side A, I'm going to go ahead and use the same ratio that I used to find the side B. I'm going to use sine of 15 degrees over 16, and then I'm going to set sine of 120 up over the side A, which I want to solve for. So I'm going to cross multiply again, and that's how we went from here to here. I want to get A by itself. So this is very, very similar, right? We're doing the same thing over and over. So I divided both sides by sine of 15, and that's how we went from here to here. Once we isolate A, we can put all of this in our calculator and hit enter, and we get 53.5, which makes sense. That should be the largest side since it's opposite the largest angle. So law of sines is great until it isn't. It's actually still great, but we have to be really, really careful. Sometimes we can use law of sines, but if we're using law of sines on a triangle with side-side angle, or as we had fun in class, angle side-side, if we identify that we have a triangle with angle side-side, we have to be aware that we could have 3 different cases. And so I'll quit talking and let's just go ahead and look at what I'm even talking about. So once again, if I were given this information, okay, I would draw my triangle, and most likely I would draw this one first, right? Can you see that I gave myself, right, the angle A is 32, the side opposite A is 4, that's side A, and then side B is 7, and I would draw it like this and everything would be good. But then I'd stop and I'd say, wait a minute, did you notice that I don't know anything about angle C, and I don't know anything about side C? They don't give me that information. So technically, I could swing side A, right? I could swing that 4 in, and I could also, using the same information, draw the triangle a second way. So am I going to ask you to draw 2 triangles all the time? Not necessarily. I'm showing you the 2 triangles so you understand how sometimes if I'm given an angle and then 2 sides, I have to be careful. So what is this going to look like? Let's say I'm given the same thing and I don't have to have the pictures. In fact, the pictures, well, I'm going to leave them here for a second. So let's go ahead and look at this first triangle, because when we're starting to solve a triangle that has angle side-side, we're always going to be finding angle B as an acute angle. If that didn't make sense to you, don't worry. It will in just a little bit. So I'm going to look at this, and I notice that I'm given angle A and side A. So that's how I'm going to start my law of sines, right? I'm so happy I'm given an angle A and a side A. So I say sine of angle A, so sine of 32, is to 4 as sine of B, which I do not know, right? I do not know angle B is to side B. So I set up my proportion, And I go ahead and do what I always do, right? We're cross multiplying. That's how we get from here to here. And then we notice that, oh, this one's a little different because my unknown is angle B. So I want to get sine B alone. So that's why from here to here, I divided both sides by 4. And so now what I'm going to do, that's the bell, but nope, it's not the right bell for students to come pouring in. All right, so what I'm going to do is put this side in my calculator. Yes, I don't have B isolated, but I do have sine B isolated, and that's good enough. I put that left side in the calculator. It gives me this. I'm, of course, making sure that my calculator is in degree mode, right? That's really important. And so now I see, oh, I got to do inverse sine because this line right here tells me sine of some angle, sine of angle B, is equal to 0.92. And to find out what angle has a sine of 0.92, I put the next line in my calculator. I put inverse sine 0.92, hit enter, and it gives me the answer that B is 67 degrees, which looks reasonable for the picture that I drew. Normally, when we're done with using the law of sines, we're done. We got it. But once again, you have to be very, very careful of a side-side angle or an angle side-side. And that's what this is, right? We've been given an angle and two sides that are not, like this is different than a side angle side. Now we're going back to geometry, right? But whenever we're giving this, we have to stop once we get our answer. All right, so we got B. All right, it says find all the angles. All right, we're not quite done with this. It says find angle C and B. All right, so let's finish this triangle, and then we'll talk about how there's actually a second triangle to solve for. So let's see. If angle B is 67, then we're going to go ahead and say what we've got. 32 and 67, that's 99, and we're going to subtract 99 from 180, and we're going to get what, 81? Does that sound good? So, and wow, that actually angle C does kind of look like it's an 81 degree angle. So my point, what I keep reiterating is we're not done. Anytime it's angle side side, we are not done. We have to double check that there's not two. Oh my goodness, how can I just move this? Let's see. Let me try. Okay, so we've got to double check that there's not another triangle involved that we have to solve for. All right, you know what? Let's do this. Boop. And it's all gone. All right, so we already know, you saw it, you wrote it down. We solved for angle B and angle C. Now, you wrote it down, but I don't have it. So wait, let me go back. So angle, let's write it down. So we had angle A, of course, is 32, and angle B is that 67? Yep. And then angle C is 81. Okay. Now I'm going to get rid of the rest of the mess that's just interfering with the lesson. Okay. So let's look at what else we have to do. Here's the deal. We're going to look at angle B, which is 67 degrees, and we're going to see if its obtuse angle can also work. So I want you to look at this angle B and this angle B. Can you see that intuitively, if you add them together, they'd add up to 180? Well, what we're going to do is we're going to take 180 and subtract whatever the angle measurement was of the original angle we got. So we're going to say 180 minus 67, well, that's 113. And we're going to see, which is reasonable, right? And we're going to double check to see, does 113 work in this triangle? So let's see, does it work? Well, if we add 32 plus 113, that gives us 145. That leaves enough room for a third triangle, right? Because if we take 180 minus 145, we'll see that we have 35 degrees. And that looks very reasonable. So to sum it all up, what do you do when you have angle side side? You go ahead and use law of sines. You go ahead and solve for whatever it is that they asked you to find, whether it was, in this case, 2 angles or 1 angle, whatever they ask you. And then you stop and the angle B, it's always going to be, maybe not angle B, but it's the angle that they definitely ask you to find. You're going to stop. You're going to subtract it from 180. You're going to take whatever you get, and you're going to see if it works with angle A, and then this would be plus angle B, and so that you could have an angle C that works. All right, so what we would do, which we're not going to do, we would, because we don't have time, it's going to be a super long video as it is, we would stop and we would use law of sines. Actually, we don't have to use law of sines. We're done. They just asked us for angle C and angle B. So we have 2 possibilities. All right, that felt like a mess. Hopefully that made sense to you. I know in class it went really well. If you're watching this because you missed class, then keep listening because these next 2 slides are going to help. So here we're given another angle side side. If I were to draw a picture, let's see, let's make that angle A that looks pretty much, and then this is going to be side A, and then that's B, this would be side B. I can see right away, right? I'm given this angle, this side, this side. It's an angle side side, so I'm going to be on the lookout. First, I'm going to set up my law of sines. Note that they did it backwards. That's okay. I'm going to cross multiply, which leads me here. I'm going to put this in my calculator, take the inverse of whatever answer that gives me, and that's going to give me that B is equal to 25 degrees, which is great, right? So then what I would say is one of my possibilities is 25, and I would double check. So this is what they're doing here. To find angle C, if we've got angle A, so angle A is equal to 58, they gave me that. Angle B is equal to 25, we just figured that out. Then we're going to add 58 and 25 together, subtract them from 180, and we get that our third angle, angle C, is 97. So this triangle would work. Okay, we've got one triangle that works. Now, because it's angle side side, we have to make sure that we don't have 2 triangles that we might be dealing with. So we take this 25, we subtract the 25 we're going to take the 25, we go ahead and add it with the 58 that we already had. So what does that give us? Let's see. So that's 13, carry the 1, that's 83. And so what we're going to do right now, let's just back that up. I think it was a bad idea to make the video after I just did the lesson in class. So let's do this. If angle B is 25, then what we're looking for now is that's our acute angle. We're looking for the obtuse angle. And so to find the obtuse angle, it's 180 minus 25. So 180 minus 25, and there it is right here. I don't know why I'm working it. The work is right here, is 155. We're like, okay, that's a possible obtuse angle for a second triangle. But then we have to see, is that going to work? If we had 155, and that would be for angle B, right? If we had that for angle B, and we already have 58 for angle A, we can already see it's not going to work, right? If we add these together, we're way over 180. What do we add even? Let's see, we're at 3, carry the 1, we're at 213. There's no room for a third angle. In fact, what this work shows here is that our third angle would have a negative measurement, which we can't have that. So in this case of angle side side, there's only one triangle. That's why we talk about ambiguous case. We could have 2 triangles that work for angle side side, or only one. And in this case, they're going to give us another example where we're given an angle, a side and a side, We can tell it's angle side side just because they keep giving us angle A and side A and then side B. We're going to cross multiply. And when we put this part into our calculator, we see that it gives us 1.3395. Is there an angle out there that has a sign that's greater than 1? I think not. And if you don't believe me, just go ahead and pause and put the inverse sine of 1.3395 and tell me what it gives you. It's just not possible. So even the first angle doesn't work, which means no triangles are possible. So once again, you can have three cases, right? You could have a side-side angle that ends up with two triangles that work. I don't know, where we get an acute angle for angle B and an obtuse angle for angle B, and both of them work. So you'd have to solve for two triangles. Or you'd be given an angle side-side, and you would solve, and it would work, like right here. It worked for my first triangle, but when I went back and subtracted 25 from 180 to find my obtuse, all right, it's not letting me, there we go, to find my obtuse angle, man, there was no room for that obtuse angle. It couldn't make a second triangle. And so for this one, there's only one triangle out of the information they gave us about angle side side. And in the third one, just to reiterate, sometimes they're going to give us an angle side side, and we're going to do our best to set up our law of sines, and we're still going to end up empty-handed because no triangle exists with these dimensions. Okay. What if, okay, so I really got into when I made this tutorial, angle side, and side angle, brings back maybe some good memories of geometry or some, terror times. I don't know how you felt about geometry. Don't worry about this. The only thing you need to identify is when you're dealing with an angle side. Okay, that's important because those are the three that we just talked about ad nauseum, whatever. You know what? I'm just going to stick to the math here. So here we go. Law of cosines. When are we going to use law of cosines? Well, let's see. When we're given a triangle like this, we're looking at it going, where's our angle in our opposite side? And we don't see it. So that calls for something different than law of sines. And that's when we're going to have to use law of cosines. Do you have to memorize these? Absolutely. But as we talked in class, really simple way to remember them, right? A lot of Pythagorean theorem, the same letters appear at the beginning as a side and at the end as a, that should be a capital C, by the way. And so what we're going to do is we're looking at this triangle. We realize we have to use law of cosines. And so what we're going to do is, let me move this a little bit so I can fit, let's see, there we go. Oh, find largest angle first. So that's an agreement we have to have. And in class, everybody knew that the largest angle was A because it's opposite the largest side. And so we set up, this is our work. So we set up, we used the law of cosines in class, and we set up, we set up our first line to reflect that we need this formula because we're going to start with our largest angle. So we started with our largest side. We set up and we started plugging things in. That's how we got from here to here. We plugged things in. Then from here to here, we are subtracting the 85 from both sides. Then to get rid of the negative 84, we are dividing both sides by negative 84. And finally, we isolate cosine A. And then to find what angle A is equal to, we put inverse cosine of 0.25. And we get, ta-da! Angle A is 75.5 degrees. And so I believe that it asked us to do more than, let's see, angle A is 75.5. We could continue this process to solve for the rest of them, but are we going to use law of cosines? No, we would use law of sines. So if we were going to go ahead and find, we don't have to use law of sines one more time, right? To find, let's say we're going to go for angle B, we'd set up what? Sine of B over 6 is equal to, I'm going to use the sine of A, which A is 75.5, is to 8. We'd cross multiply, we'd solve for B, and then we'd go ahead and add angle B, add angle A, subtract them from 180 to find angle C. All right, but whenever possible, we're going to use law of sines. All right, so here's kind of a wimpy application. We've got a triangular platter. There we go. Let's see if I can make this bigger. So we drew a picture of the platter. Angle is 62, and then the angle, or says the angle between the two sides is 62 degrees, so the two sides are 13 and 15, and we want to know the third side. We are not given an angle in its opposite side. Boo-hoo, we cannot use law of sines, so we're stuck with law of cosines. We set it up. That's what the first line reflects. We set it up. But the cool thing about finding a side using law of cosines versus finding an angle is once you're done with plugging everything in, then you just put this into your calculator, hit enter, and you get the 210.9. We're almost there. We need to take the square root of both sides, which leaves us with the 14 point, can't tell if that's 5 or 3. That's a little messy, but if you put in your calculator, you can tell. Once again, if we're taking the square root of both sides in a normal equation and just a random equation that's not attached to measurement, we would put plus or minus 14.3 or 5. But in this case, we're talking about the length of a side, and so we need to just keep the positive answer. And our last one is our homework, 7 through 19 odd, skip 11, and I believe Anna told me that the 6.2 assignment, I believe 21, we're going to go ahead and drop. I hope this made sense. I feel better in knowing that most of you had an easy time with this last year in 2 trig, and it's just a simple review. So make sure you get your homework done and check your answers and come back in class ready to be a participating member of your pod. Thanks for joining me.